Have you ever, chatted with an AI? Maybe had it draft an email for you or even help brainstorm some ideas?
Yeah, they're pretty much everywhere now.
Exactly. These
Yeah.
large language models, LLMs, they're popping up all over smartphones, business tools, you name it.
hmm
But have you ever stopped to wonder, like really wonder, how these things are actually built and kept running?
It's a fascinating process.
Yeah.
Much more involved than just typing in a prompt, that's for sure.
Totally. So today we're doing a deep dive into that whole journey, what we call the LLM life cycle.
Right. From the very beginning to the end, and then kind of looping back.
We're going to unpack every single stage, from the first raw data point all the way to it working out in the real world.
And we're looking at a general first.
Yeah, first the general steps, and then we'll zoom in on how a big data platform like Snowflake handles this whole complex process.
Which is really interesting how platforms are integrating this now,
Our mission here is really to turn all these technical steps into something clear, maybe even surprising, and definitely understandable.
giving you that shortcut to knowing what's actually going on behind the curtain.
Exactly. We'll cover out the massive data collection, the user interaction bit, and how they keep these things maintained.
Okay, sounds good. Where do we start?
So let's kick off with the absolute foundation, data collection. Step one. This is where everything begins.
That the scale here is just mind-boggling.
We're not talking small files. Think massive, massive volumes, terabytes, even petabytes of data.
Unbelievable amounts.
And it comes in every format you can imagine. Text, audio, video, images.
From all over the place, too.
Totally global sources, websites, books, tons of code, research articles, public data sets, social media. It's a huge undertaking.
And what's really key here, maybe not obvious, is why you need such a wide range of diverse data.
Ah, yeah. Tell us about that.
Well, imagine trying to learn about the world just by reading, say, only news articles. You'd get a very skewed view, right?
Limited
Yeah.
perspective.
For an LLM, this diversity is absolutely essential. It's how they get broad language coverage and a real understanding of how humans communicate.
So it stops them being too narrow.
Exactly. Without it, you get a model that might be great at one specific thing, but completely useless for anything else. It needs that breadth.
That makes total sense. Okay, so once you've somehow gathered this ocean of raw data, what's next? Must be messy.
Oh, incredibly messy. Which brings us to the next, and I'd argue, super critical phase, data preprocessing.
Cleaning up the mess.
Pretty much. Here, the main focus is usually on that huge pile of unstructured text, trying to make it actually usable.
So what does that involve?
We're talking about really important processes, like scrubbing the data clean, getting rid of duplicates. You'd be amazed how much repetition there is.
I bet.
Filtering by language, and maybe most importantly, removing sensitive data. Privacy is a huge concern.
Right. What kind of tools do people use for that?
Things like regex,
Mhm.
which is kind of like a superpowered search and replace for text patterns, and also sophisticated NLP pipelines, these automated workflows designed specifically for processing human language. Data cleaning frameworks, too.
Wow.
And this step is genuinely foundational. You can't skip it or skip on it.
Why is it so critical?
Well, think about teaching a kid using a textbook full of errors, repeated sections, maybe even wrong facts.
They'd end up very confused. Or
Yeah.
worse.
Exactly. It's the same for LLMs. Pre-processing makes sure the input data is clean, hopefully less biased, and actually useful for training.
Avoids the garbage in, garbage out problem.
Precisely.
Ah.
Without this careful cleaning, you risk building an LLM that's ineffective, maybe reflects nasty biases from the raw data, or is just plain unreliable. We've seen chatbots go off the rails because of this.
Okay, very important step then. So data's clean. Now what?
Now we hit a really key transformation, tokenization.
Tokenization. Right. What's that?
This is where we convert that clean text into smaller, sort of digestible units. We call them tokens.
Okay, like words.
Sometimes words, but often smaller pieces, like subwords. Think tokenization might be broken down, or even individual characters.
Interesting. And how's that done?
There are common techniques like byte pair encoding, or BPE, word piece, sentence piece. Different methods.
And the result?
The output is always numerical tokens. Basically, unique IDs for each token of subword piece. Language becomes numbers.
Why turn it into numbers?
Well, that conversion is absolutely necessary because neural networks, at their heart, they're mathematical. They crunch numbers.
They don't read English like we do.
Exactly. They don't understand language directly. Tokenization is the essential bridge. It gives the computer a very precise numerical map of the language.
Okay.
And this lets the model find deep patterns and relationships across millions, billions of sentences. Even if the words are different, the token IDs might show similar structures or meanings.
So it can see connections we might miss.
Yeah, like recognizing that cat and kitten are related, even though different words. The token patterns help reveal that closeness.
Got it. So numbers ready. Now the big part.
Now we get to the core, the real brain-building phase, model training. This is the heart of the LLM lifecycle.
This is where the learning happens.
Absolutely. The model learns by processing sequence after sequence of those tokens we just made.
How does it learn?
It constantly adjusts its internal weights. Think of these as connection strengths between concepts using a specific architecture, usually transformers these days. That's a type of neural network.
And I hear this takes a lot of computer power.
Oh, astronomical amounts.
Yeah.
Seriously, heavy-duty computation. You need fleets of GPUs or TPUs running in huge distributed clusters.
Wow. So what does learning actually look like for the model?
Good question. It's basically identifying incredibly complex patterns, predicting what token comes next in a sequence, building up a statistical model of how language works.
So it's learning grammar, meaning context.
All of that, yes. The grammar, the syntax, the semantics, all learned statistically from the data. And about that compute power you mentioned.
Yeah.
Training just one large model can use as much energy as a small town over several months.
That's incredible. It really puts it in perspective.
It's a massive, massive investment in data, time, and energy.
Okay, so after all that intense training, that huge effort, you need to check if it actually worked, right?
Exactly. You can't just assume it learned well. That brings us to model validation.
Making sure the brain works properly.
It's essentially, yeah. This means testing the model rigorously on validation data sets. That's data it has never seen during training.
Why unseen data?
To check its generalization ability. Can it apply what it learned to new situations? We check things like accuracy, coherence, does it make sense, and monitor its loss, which is basically how often it's still getting things wrong.
How do you do those checks?
Using special validation scripts and established benchmark data sets that the whole field uses for comparison.
And the main goal here?
It's absolutely vital. Preventing what's called overfitting.
Overfitting?
Yeah, you don't want a model that just memorized the training data perfectly but can't handle anything new.
Like a student who crammed for a test but didn't really understand the subject.
Perfect analogy. Validation ensures balanced learning, so the model is reliable on messy, real-world data, not just the clean training set. Otherwise, it might seem brilliant on questions it saw before, but give you complete nonsense for anything novel.
Right, crucial for real-world use. Okay, so training, validation. Are we done yet?
Almost. There's another step. It's optional, but really powerful, fine-tuning.
Optional. Tell me more.
So imagine you've trained this huge general-purpose LLM. It knows a bit about everything. Fine-tuning is like sending it to grad school for a specific subject.
Ah, specializing it.
Exactly. You specialize it for specific use cases, maybe medicine or law or finance.
How does that work? Do you use different data?
Yes, you use much smaller, highly focused, domain-specific data sets. It could be structured data, text, whatever fits the specialty.
So you could make like a legal expert LLM.
Precisely. The value is immense because a general LLM might know some legal terms, but a fine-tuned one becomes much more precise, more useful for actual legal work.
That sounds incredibly valuable. Any downsides?
Well, it's a bit of a balancing act. If you fine-tune too much on a very narrow data set, the model might forget some of its general knowledge. It could become less flexible outside its specialty.
Interesting trade-off. Okay, so model is trained, maybe fine-tuned, it's ready.
Yeah.
How do we actually use it?
That takes us to model deployment, getting it out there so people or applications can interact with it.
Making it accessible.
Right. And deployment can happen in different places. In the cloud, often as a service you subscribe to.
Software as a service, SaaS.
Exactly. Or on-premise, inside a company's own data centers.
Right.
Or even at the edge, directly on devices like phones or sensors.
And how do things talk to it?
Usually through an API, an application programming interface. It's like a standard contract for how software components communicate.
What tools help with deployment?
Things like Kubernetes are huge here. It helps manage and scale the LLM software components automatically. And API gateways handle incoming requests, security, that sort of thing.
Seems complex.
The practical side of deployment is crucial. It's not just switching it on. You need it to scale up or down to meet demand, potentially millions of users.
Right. Handle the load.
And it needs to integrate smoothly with whatever applications are using it, become a reliable part of a bigger system.
Okay, deployed. Now, I've heard a lot about prompt engineering. Is this where that fits in?
Absolutely. This is where the human-AI collaboration really comes into focus, and it's something you, as a user, are doing all the time, maybe without realizing it.
How so?
Prompt engineering is basically the art and science of crafting the right instructions, the prompts, to get the best possible response from the model.
So it's about how you ask the question.
Exactly. It's about understanding how the AI thinks and phrasing your request in a way it understands best. Key strategies involve tuning the prompt, like trying different phrasings.
Iterating.
Yeah, iterating until you get what you need. And designing templates to make sure the output is consistent in tone or depth or relevance for a specific task.
So the user plays a big role in guiding it.
A critical role. It's like learning how to talk to a very powerful but very literal assistant.
Give me an example.
Sure, just asking, write an email might get you something bland. But prompting like, write a short, polite email to my team lead, asking for feedback on the Q3 report draft, deadline is Tuesday, that gives it guardrails.
Much more specific.
You get a much better, more targeted result.
It's all about precision and clearly stating your intent.
Okay, makes sense. And all this leads to the moment we actually see the result, right?
Right. Which brings us to inference. That's the live interaction part.
When the AI actually generates the answer.
Yes. It's generating responses based on those prompts you feed it, usually in real time. Inputs are coming from apps, websites, chatbots.
It has to be fast.
Oh, yeah. Very low latency is key. Real time or near real time. Milliseconds matter.
And this inference stage is what we, the users, directly experience. That's it. The immediate answer, the quick summary, the creative text that pops up. That's inference in action. It feels instant, almost magical, but it's the payoff from all those previous steps working together.
Incredible. Is that the end of the line?
Not quite. There's one more crucial, ongoing step: monitoring and feedback.
Ah, keeping an eye on it.
Constant vigilance, really. These systems aren't set and forget.
What does monitoring involve?
It means continuously collecting data like system logs, how the model's being used, usage metrics, and really importantly, user feedback. Did it do a good job? Was the answer helpful? Biased.
And what do you do with that data?
You use it for ongoing performance reviews, security checks, ethical assessments. Is it fair? Is it safe? And tracking costs.
How is that tracked?
Using monitoring systems, audit trails, cost trackers. It's a continuous loop.
Why is this continuous part so important?
Because models can drift, real-world data changes, language evolves, new biases might creep in if you're not watching carefully.
So it needs constant tuning, almost.
Constant oversight, certainly. Monitoring helps maintain accuracy, ensure fairness, catch security issues early, and manage the costs, which can be significant. It keeps the LLM useful and responsible over its entire operational life.
Wow. Okay, that's a lot of steps, an incredible journey just to get that AI response.
It really is. Complex, multi-stage, requires huge resources.
So we've mapped out that general life cycle, but you mentioned earlier how platforms like Snowflake are changing the game here.
Right. This is where it gets really interesting for businesses, I think, how a robust data platform can integrate and optimize these steps.
Bringing the LLM capabilities closer to where the company's data already sits.
Exactly. What's fascinating is how an enterprise platform like Snowflake can streamline and govern this whole workflow. Often it can plug right into existing data pipelines, which is a huge plus.
Less data movement, less complexity.
That's the goal,
Yeah.
reducing the need to shuttle massive data sets between different systems.
Okay, so let's walk through the life cycle again, but this time through the lens of Snowflake. How does data collection look?
Well, Snowflake calls it ingestion. It's built to pull in all sorts of data structured, semi-structured like JSON, unstructured text from wherever it lives.
Cloud storage, databases, APIs.
Yep. Cloud buckets like S3 or Azure Blob, other databases, streaming sources via Kafka, even direct file uploads. They have tools like Fivetran integrated or Snowpipe for continuous ingestion.
Gotcha. And what about that critical pre-processing step, the data cleaning?
This is a key difference. Pre-processing can happen inside Snowflake.
So you don't need to pull the data out.
Right. You can use standard SQL pipelines, which many analysts already know, or Snowpark, which lets you run Python code directly within Snowflake for more complex cleaning tasks.
Python right in the database.
Yeah, alongside SQL. And they have features like streams and tasks to automate these cleaning jobs when new data arrives. So cleaning, format conversion, adding metadata tags, it can all happen centrally.
That sounds much simpler and more secure.
It's a big advantage. Your raw data doesn't have to leave Snowflake's security boundary just to be cleaned. You bring the compute to the data.
Okay, clean data inside Snowflake. What about tokenization? turning text to numbers.
Again, this can often be handled within Snowflake too. They have built-in SQL functions for text manipulation. They can do some tokenization.
Or Snowpark again.
Exactly. If you're integrating with external LLMs, you typically use Snowpark libraries to handle the tokenization needed for that specific external model's API. It keeps it within your workflow.
Right. Now, you mentioned a strategic choice earlier, model selection in Snowflake.
Yes, this is a really interesting fork in the road within the Snowflake ecosystem. Architects need to decide. Do we use Snowflake's own native LLMs called Cortex functions,
Cortex.
which run directly inside the database using SQL commands?
Hmm.
Or do we use Snowpark to call out to an external LLM API like OpenAI's GPT models or Anthropic's Claude or something from Azure?
What drives that decision?
Several things. Security is a big one. Cortex keeps everything strictly inside Snowflake. Performance is another. Cortex can be super fast because there's no network hop to an external API.
But external APIs might have more powerful models.
Potentially, yes. External APIs often give you access to the very latest, largest models. So it depends on the use case, the data sensitivity, latency needs, and cost too.
Okay, choices. Now, what about fine-tuning, that specialization step? Can Snowflake do that?
This is a crucial distinction currently. As of now, if you need full fine-tuning retraining a model on a large custom data set, you have to do that outside Snowflake.
On platforms like Azure, OpenAI, Databricks maybe?
Exactly. Snowflake's Cortex functions are designed for zero-shot or few-shot prompting.
Meaning they can understand instructions without examples or with just a couple.
Correct, but not full-scale retraining with custom data, at least not yet. That has to happen externally, and then you might call that fine-tuned model via Snowpark.
Got it. So if you do use an external model, how does Snowflake manage that connection, the API integration?
It handles it securely through Snowpark. You can make calls to external API gateways. But the key is Snowflake manages the credentials, like API keys.
Securely stores them.
Yes, securely within its environment. And it handles the responses coming back, all within Snowflake's governance framework.
So the sensitive keys don't leave Snowflake.
Right. It's a big deal for enterprise security and IT teams. They keep control and visibility even when interacting with external AI services. You get the power without compromising your internal security.
Makes sense. And prompt engineering, still important.
Oh, absolutely critical. Whether you're using the native SQL Cortex functions or calling external models via Snowpark, crafting good prompts is still essential.
How do people manage prompts in Snowflake?
You often see SQL-based prompt templates being used for Cortex or specific prompt management libraries within Snowpark for the Python calls. Still an art and science, just managed within the platform.
Okay, and then the inference part, the actual user interaction.
This becomes really seamless in Snowflake. For Cortex, you literally just write a SQL query that includes the Cortex function call.
So analysts using SQL can directly invoke AI.
Exactly. Or for external models, a Snowpark job handles the API call and brings the result back. Users can interact via Snowflake worksheets, dashboards, or custom apps built on Snowflake.
That really lowers the barrier to entry.
It democratizes it, in a way. People already comfortable with Snowflake and SQL or Python can start leveraging LLMs without learning a whole new stack or moving data around constantly. AI gets closer to the point of decision.
Very powerful. You also mentioned automation.
Yeah, Snowflake streams and tasks are great for this. You can set things up so an LLM function gets called automatically whenever new data arrives.
Like summarizing new customer reviews instantly?
Perfect example. Or classifying incoming support tickets. Or you can schedule batch jobs, like processing documents overnight. It removes a lot of manual work.
And finally, that all-important monitoring and governance piece.
Snowflake has a really comprehensive framework for this, built right in. It tracks everything.
Like what?
Query history, who ran what when, usage logs for the LLM functions, auditing for any external API calls, resource monitors to track costs and set alerts.
So cost control is built in.
Yes, and crucially, all the standard Snowflake governance applies. Role-based access control, RBAC, data masking policies. You control who can call the LLMs and what data they can potentially use or see.
So that model validation piece fits in here too.
It's part of the ongoing monitoring. You track performance, maybe use specific datasets within Snowflake to periodically check accuracy and drift, all governed by the platform's rules.
That sounds incredibly integrated.
It is. It provides that trust, auditability, and manageability that big organizations absolutely need when they start deploying AI more widely. It helps tick all the compliance boxes.
What an incredible deep dive we've taken today. Seriously, from just raw data scattered everywhere.
To these incredibly complex intelligent systems.
Yeah, unpacking the whole life cycle, the steps involved, the sheer scale of it, and then seeing how platforms like Snowflake are working to integrate all that complexity.
Bring it into a more streamlined, governed environment, right where the data lives. It's quite a shift.
It really is. So if we try to connect this to the bigger picture, what does understanding this life cycle really tell us?
Well, I think it reveals the enormous amount of engineering, sophisticated data management, and just continuous effort that goes into making AI work.
It's not just a clever algorithm.
Not at all. It's not just the model itself, but this whole ecosystem, this multi-stage process around it that's constantly being tweaked and improved behind the scenes.
Which leads to a really interesting question, I think, for you listening. As these LLM life cycles get more deeply embedded, more automated within data platforms.
Making AI development potentially faster and easier.
Right. How might that change the speed of AI innovation, and what kinds of custom AI solutions might we start seeing emerge in, well, pretty much every industry?
It's definitely something to think about. So maybe the next time you get one of those surprisingly insightful or creative responses from an AI, just take a moment. Consider the incredibly intricate, continuous journey it took to get there. From petabytes of data, through all those cleaning and training cycles, right down to that specific real-time interaction you just had.
A lot going on under the hood.
A massive amount.